Hello. In today's topic, we actually begin the entire process of conducting what's known as a hypothesis test, which is really the heart of inferential statistics, and is kind of really what the whole course has been building up to. So it's a pretty big day. The type of questions that we want to answer are ones like the following. We usually are wanting to test some claim that's made by a company or a person that maybe is under scrutiny. So consider the following situation. A soda company claims their drinks have no more than 40 grams of sugar. As a health specialist, you test this claim by sampling 35 of their drinks. A, what would the average of those 35 drinks have to be for you to not believe the soda company? How sure are you in your answer to part A? We're going to consider this question at the end of the lesson. So for example, if the soda company claims their drinks have no more than 40 grams of sugar, if you find that that sample has an average of 40.1, is that enough? What about 42 or 44 or 45? And where is that cutoff where you're going to start to say, yeah, that's probably like too far away from 40. I'm going to start to not believe the soda company's claim. So that's the type of question that we like to answer. Uh, I should note that for today's topic, we're going to be assuming the population standard deviation is known. That means we're going to be using z-scores and a standard normal curve. Later, we'll do hypothesis tests where we will assume that we don't know the standard deviation of the population, and we would be using then a t-test, or we'd be using t-distributions. So recall from a prior lesson the steps for a hypothesis test. The first thing we do is we state the claim mathematically and verbally, and then we identify the null and the alternative hypothesis. We specify the level of significance. So what's the probability we would like to have for making a type 1 error, or essentially the level of significance is what's the probability of some event that we're going to consider if it's more unusual than this probability, that is too unusual. Step 3 is determine the type of sampling distribution and then draw the graph. We're going to be using the normal curve today. Step 4 is calculate the test statistic, that is the z-score of the item that we observed, and then find that corresponding p-value. Compare that p-value maybe to the confidence level, or make a generalized description and either reject the null hypothesis in favor of the alternative, or say that we don't have enough evidence against the null until further notice. The null stands as it is. So that's the steps. We're going to focus right now just on steps 5 through 7, and then we'll do a couple that involve all of them. So recall, a p-value for a hypothesis test is the probability of obtaining a sample statistic, some measurement, with that value or a value more extreme, if the null is actually true. So we use p-values to make decisions. The decision rule based on the p-value is, well, there's only two things that can happen. We use a p-value to make a conclusion based on our hypothesis test. We can compare that p-value with the confidence level. If our p-value is less than or equal to that confidence level, then we say we've observed an unusual enough event. We're going to reject the null hypothesis in favor of the alternative. If our p-value is bigger than that confidence level, we have not observed an unusual enough event, and we don't have enough evidence against the null, so we fail to reject it. The null stands until further notice. Recall that alpha or confidence level is predetermined before the test. You can't conduct a test and all of a sudden say, oh wait, I'd like to run that with a 5% or a 10% confidence level now in order to make this be a finding. You need to determine before the test what type of probability you would like for type 1 error, or what's going to be unusual. As an example, let's say we have a p-value for a hypothesis test. We observe something that only happens 2% of the time if our null is actually true. What would our decision be if we set the following level of significance values before that test was run? If we set the confidence level to be at 5% and we observe something that occurs 2% of the time, then we would have enough evidence and we would reject the null. So we would say since p is less than alpha here, because 2% is less than 5%, we have enough evidence to reject the null in favor of the alternative. We observed something that was unusual, rare enough. However, if our confidence level was set to be at 1%, so we need something that occurs 1% or less of the time, and we observe something that occurs 2% of the time, we have not observed an unusual enough event. So we would say since p is greater than alpha, we do not have enough evidence to reject the null. And the null hypothesis would stand until you did another test and maybe found some sample statistic that occurs 1% or less of the time. Or if you can never do it, then maybe the null actually is true, but you can never really know because you could always continue to run tests. To obtain the p-value for a test statistic, because right now I just gave them to you, you need to know whether this is a left-tailed or a right-tailed or a two-tailed test. So to find the p-value for a hypothesis test, after determining the hypothesis test, standardized test statistic, that's usually the z-score, could be a t, also if we're doing a t-distribution later. The test statistic's corresponding area, do one of the following. For a left-tail test, the probability is area to the left. For a right-tail test, the probability is area to the right. For a two-tailed test, the probability is equal to 2 times the area in the tail of one of them. Pick either the right or the left side and double it. Most of the time people are going to do the left side because that's what they were when we had distribution tables before. It was always area to the left. Then you double it. So if it's a two-tail test, you find the area in one of the tails and then double it. Example, find the p-value for the given test statistic and the type of hypothesis test, then decide whether to reject the null if our confidence level is set to be 5%, which means we need to find something that has a probability less than 5%. If it has a probability more than 5%, we have not observed an unusual enough event. Let's say we have a test statistic that has a z-score of negative 2.2. We're running a left-tailed test. I want to find the probability. I would run normal CDF. Pick something way to the left. This is always our left bound, right bound, our mean, and our standard deviation. Since it's a standard normal curve, our mean is 0, our standard deviation is 1. Our left bound technically is negative infinity, so just pick a very large negative number, negative 1,000, all the way up to our right bound is our test statistic of negative 2.2. And you'd run that. You type it in the calculator. To save us a little bit of time, I will tell you that the probability is 0.0139. That probability is about 1.4%, and that is less than the 5% threshold value for our confidence level. So we have enough evidence against the null. So we would say we would reject HO, the null, in favor of the alternative. So we would rule in favor of the alternative. We found an unusual enough event. It's probably the case that the null was false. Second scenario, if you're running a two-tailed test, well, it is symmetric, so all I need to do is find the area of one of these and then double it. You can either do the right or the left. It does not matter. I'm going to do the left and just double it. So my left bound is negative 1,000. My right bound is negative 1.8. For the left bound, this is negative 1.8. Or for the left tail. For the right tail, this is positive 1.8. I run that in the calculator, and I get that this is an area corresponding to a probability of 0.036. If I double that then, so the total value would be 2 times that, because it's got two tails, 0.036. I would get 0.072. That's something that occurs 7% of the time. And that is not unusual enough because our confidence level was set to be 5%. So we do not have enough evidence against the null. We fail to reject. I should just say fail to reject the null hypothesis, HO. I'm going to give you a chance to try. So find the p-value for the given test statistic and type of hypothesis test, and decide whether to reject the null if our confidence level is set to be 1%. The z-score is going to be 3.1, and you are going to be doing a right tail test. So you're trying to find the area that is right there. I will pause the video now, give you a chance to try it, and then come back once you've had a chance to try it. Okay, welcome back. You should have found that your p-value was, in the calculator it tells you it's 9.7 e to the -4, which really means, that's scientific notation, it's 0.0009. That is less than 0.01, so you would reject the null in favor of the alternative. You observed a very unusual event, so unusual that it actually occurs less than 1% of the time, so it's probably not the case that the null was true. It must be that probably the alternative is true. And that's the last steps for the hypothesis test. Those are steps 5 through 7. Now we can kind of go through what it would look like if we're going to do the whole entire test. So we are now going to discuss how to perform a hypothesis test for an average, assuming the standard deviation for the population is known. We will be able to test claims such as a weight loss program claims its average weight loss is 15 pounds for males. Those are the types of claims that we want to be able to test and see if they appear to be statistically valid or not. So we are doing what's called a z-test for a mean when we are testing the population mean. We can use this when the sample is random, the population is normally distributed, or for any population when the sample size n is at least 30. The test statistic for the test is our sample mean. The standardized test statistic is a z-score, where we take the mean minus the population mean, and we then divide it by our standard error. And that gives us our z-score. The steps for this are shared in this section in your book. I condensed these down to 5 steps in the examples. I think the textbook gives 8. The first one is verify that we can run this test, develop our hypotheses, specify the level of significance before we run our test, find our test statistic, our z-score, find the area or probability corresponding to that z-score based on what type of test that we are running, left-tailed, right-tailed, or two-tailed, compare that to the confidence level, and then determine if we are going to be rejecting the null or failing to reject the null. So example, a food manufacturer claims that eating its new cereal will lower your total blood cholesterol by an average of 5. That's milligrams per deciliter, but we're just going to, for the rest of the time, ignore the units, but that's what it is. A sample of 37 patients has an average of 3.8, so lower. So the question is that too low? Does it appear that they were making an invalid claim in this one? So assume the population standard deviation is 2.6. Is there enough evidence to support the claim at 5%? Use a p-value. So the first thing we need is to verify that we can use a normal distribution. We're going to assume that it was a random sample unless otherwise noted. That's a fair assumption in the textbook. Otherwise, in real life, that would need to be definitely shared. But what we are really looking for is that we have enough patients, enough samples. So because our sample size is greater than 30, and we have the sample or the population standard deviation, we know that. So those are 2 things. We need a large enough sample, and we have the population standard deviation in order to run a z-test. State the two hypotheses. Well, the null was that the average was, what they say, lower it by an average of 5. So average 5. The alternative would be not 5. Because we have not 5, our test is going to be a two-tailed test because technically it could be bigger or less than. Calculate the z-score for this situation. So the z-score, our sample average was 3.8. We're assuming the population's one is what was stated, 5 right now. The population standard deviation is 2.6, and our sample was of size 39. Up top, I get -1.2. Down below, when I run it in the calculator, I get 0.427. divide the two, and I get a z-score of negative 2.8. Now my job is to find the corresponding probability. So with a z-score of negative 2.8, that's pretty far away. That's almost 3 standard deviations away. We're probably going to have a pretty low p-value. If you draw the distribution, this is what we're working with. We have a z-score of negative 2.8, but it was a two-tailed test, so it could be positive 2.8 as well. We need to find the probabilities for either one of those, because we need to find something different than the stated value, which was 5, but for normal, that's going to be centered at 0. So our corresponding p-value is going to be twice of whatever we find for one of these tails. I'm going to do the left tail. So we're going to do normal CDF, and that's with a left bound of negative 1,000, right bound negative 2.8, mean is 0, standard deviation 1. I run that in the calculator and I get 0.0026. Doubling 26, you get 52. So this is going to be 0.0052 is our p-value. That's half a percent, 0.0052. Our confidence level is 0.055%. So we have definitely found an unusual enough event. So we would say since p is less than our alpha level, we have enough evidence to reject. Shouldn't say the null, I'll just write reject the null hypothesis in favor of the alternative that the mean is not equal to 5. So we rule in favor of the claim that the mean is not equal to 5. It appears it's probably less than 5 based on the z-score and our sample statistic that we got. So that's one example of it. I'm going to run one more so you can just see how it's done. So situation number 2 is one that we talked about in the beginning, the soda company claim. Soda company claims that their drinks have no more than 40 grams of sugar. As a health specialist, you test this claim by sampling 35 drinks and find their mean is 40.5. The population standard deviation is known to be 1.2 grams, and the population is normally distributed. Is there enough evidence to support the claim at the 1% level? We're going to use a p-value. So we can see that it's bigger because their claim is that has no more than, so that's going to be 40 or less. Is 40.5 big enough? Well, we're going to find out. So first thing, verify that we can actually use a normal distribution. Well, it was shared with us that we have a sample of 35 and we know the population standard deviation. So n is greater than or equal to 30, and we know population standard deviation is 1.2. Step number 2, state the null and the alternative. The null was the actual claim by the company that their drinks have no more than 40 grams of sugar. So the mean is less than or equal to 40. The alternative then is going to be that the mean is bigger than 40. Calculate our z-score. That should be right up here. The value that we found from our sample was 40.5. They're stating that the actual average is 40. Our population standard deviation is 1.2. Divide by the square root of our sample size. Our sample size was 35. This is going to be 0.5, and then I need to run that bottom part. I haven't done that yet. So 1.2 divided by the square root of 35. That gives 0.2. So 0.5 divided by 0.2 is 2.5. Find the corresponding probability. So our z-score is 2.5. We're in between 2 to 3, so you know it's far away. The question is this going to be far enough based on the threshold that we set? So we're right here's here's centered 0. We're over here at 2.5. And we are testing the alternative that's bigger than 40. So this is a right-tailed test. We want this or bigger. What's the probability it's actually that or bigger? So we would need to do normal CDF. Our left bound is 2.5. Our right bound is at positive infinity, but technically 1,000, just so we can set a limit. And then I run that in the calculator. When I do that, I end up with a probability of 0.006. Step 5, make our decision. It says with a p-value of 0.007. I actually got 6, maybe just a little bit of rounding. We definitely have enough evidence against the null and in support of the alternative that the soda company produces cans with more than 40 grams of sugar. So again, because our p-value is less than the confidence level, we reject the null in favor of the alternative. And that is how you can conduct hypothesis tests. Note, you can run this in the calculator as well. You go to stat, you tab over to test, and then you choose z-test. Make sure that you're using the stats item when you're in there. In this case, the null claimed population was 40, our standard deviation was 1.2, our sample average was 40.5, our sample size was of size 35. The type of test that we're running is a right-tailed test. And then you hit enter, and it will give you the following information. There's that p-value 0.0068. That's where the rounding of 0.007 came from. On the homework, though, I recommend doing one by showing all the 5 steps that we did in the note packet. There could be a chance I would ask a quiz question where you need to show all 5 steps. Otherwise, you can use technology, the calculator for the rest, but just be sure to identify all the inputs you supplied in the calculator. Essentially, you need to write down this information right here. Okay? Going to give you a chance to try one for yourself. So here's your scenario. You can use a calculator if you'd like to do the z-test, or you can run all 5 steps. A specific truck company claims its average highway gas mileage is at least 26 miles per gallon. Their competitor tests this claim by sampling 15 trucks that are found to have an average of 24.8 miles per gallon. The population standard deviation for trucks is 2.5 miles per gallon. Is there enough evidence to support the claim at a 5% level? Use a p-value and assume a normal distribution. It's important because we have a small sample size. Technically, we would run a t-test. We haven't done that yet, so go ahead and run a z-test for this. That's a fair assumption because we know that it's a normal distribution, and they gave you the population standard deviation. So go ahead and run it, and then see how you do. What you should have found was the z-score was negative 1.859. The p-value is 0.0315. So according to this, this is 3%. The confidence level is 5%. So according to this, there is enough evidence at the 5% level to reject the original claim that the average highway gas mileage is at least 26 miles per gallon. You would be then in favor of the alternative, which is that it is probably less than 26 miles per gallon. If our p-value was like 0.06, then you would say that we fail to reject the claim, and their claim stands as is. But that's it for now. Thank you very much. Have a good day.